Hello everybody, welcome to Sketching the Parabola. So we are in a grade 11 level, okay? So if we recall from grade 10, we had the form where we had y is equal to x, well I guess ax squared plus q, where a represented the concavity, so I'm going to say here, a represented the concavity, which was either the happy or the sad shape that we had, which I'll probably put here, it would be easier. And then the Q represented the vertical shift. Okay. But now, here's one thing, okay? I mean, this could have been C as well, but at the same time, it still represents the shift in the vertical plane. But at the same time, now, we want to use the Q to just add on to grade 11. So this is just grade 10. Grade 11, we are going to do the same thing, but there's two different forms. The first form, we are going to call the turning point form. So I'm going to say turning point form. The turning point form is essentially where we say we have y is equal to a times x minus p squared plus q. The only thing that we just added was the p. Okay. So in this case over here, what this implies to us is that our A is still going to be the concavity. Our Q is still going to be the vertical shift. So I'm going to say vert shift. But the P, which is the new thing, is going to be our horizontal shift. Okay. So the P is our horizontal shift, but how do we determine the horizontal shift using this? Usually what you would do is you would say x minus p, so whatever's in the bracket, and let it be equal to 0 such that you have x equals to p. Okay, so all you're going to do is whatever's in the bracket, let it be equal to 0, then you'll find your shift. And if it's positive, then it's to the left, it's to the right. If it is negative, it is to the left. Okay. But we'll touch on that on the examples and you'll actually see how that works. But just know that what these are for. And then also for the grade 11 is the what? The quadratic form. So I'm going to say the quad form. Quadratic form is when we have it in the form of y equals to ax squared plus bx plus c. Looks familiar? Yes, it's from the quadratic equations, but this is a quadratic function where we, instead of saying 0 is equal to all of this, it's y is equal to all of this. Okay? So from here, our A still represents concavity. This is still concavity. But the C represents what? Our y-intercept. Okay, so those are the two takeaways for this specific formula. Okay, now that I've gotten that out of the way, let's actually get into examples where we have to learn how to sketch these functions, and then at least you'll get familiar with all of these different parameters. Alright, so here is the whole question. Okay, so here's a turning point form function of the parabola. I'm going to explain why it's called the turning point as soon as we get further with this question. So first things first, let's analyze this function. Notice that the a value that we have is a equals to 1. And do you notice that a is positive? So therefore, since a is greater than 0, this implies to us that we'll have concave up. Because obviously the concave up just indicates to us that we're going to have happy face parabola. Okay. And then what else do we have? We have q equals -1, which indicates shifts 1 unit down because it's negative, right? But what about this middle part here, which is P, right? So remember that this is represented by P, okay? But what did I say? With the horizontal shift, in order to find the horizontal shift, you need to let the inside of the bracket be equal to 0, and you need to solve for x to find your shift. If it shifts negative, if it has a negative value, it's to the left. If it's a positive value, it's to the right. So let's determine that, okay? So in this case over here, we are going to say x plus 2, right? This is from our inside of our bracket, so x plus 2. What I actually want to rather do is color code it. So let's make this purple. So x plus 2 equals 0 implies to us when we take 2 over, it will become x equals negative 2. This implies to us that it shifts, this implies to us that it shifts 2 units. It's negative, so left. Okay. Now let's get to a point. Why is it called a turning point form? Well, clearly, with turning point form, it is essentially us saying that the turning point is within the formula. So the turning point here, this Q value is the turning point Y. And this value that we solved for now is the turning point X. So therefore, this implies to us that our turning point is going to be what? It's going to be negative 2 and negative 1. From our shift and from a horizontal shift and our vertical shift. Okay, that's only when it's in turning point form. And you can get it from the equation. A quick and simple way that you can find it is your y is equal to negative 1 and your x is going to be negative 2 because you just flip the sign. If you want to do it that way. But I like to show my work. Okay. What are we missing? Remember, in a function, you need intercepts. So how do we find the x-intercepts? So we need to find the x-intercepts, okay? To find the x-intercepts, we let y be equal to 0, right? Such that what this implies to us is we let f of x be equal to 0, such that we have 0 equals to this turning point thing here, which is x plus 2 squared minus 1. Minus 1, and then from here, we just take the negative 1 over, so we have 1 equals 2, x plus 2 square, and then all we're going to do here is going to be what? We are going to square root both sides. When we square root both sides, what are we going to have? We're going to have x plus 2 is equal to plus minus 1. Okay? And then from here, we are going to have a small little problem. So here's the issue, right? We can do it something like this, but it's more challenging to do it intuitively here. So what I would recommend in this type of question is to not do it like this, because some students actually do this, and that's why I wanted to get to this point. You're not going to do it that way, but what you are going to do is you're going to put it into quadratic equation form. So what I mean by that is we're going to expand it. So this is the same as x plus 2 multiplied by x plus 2 because it's squaring the bracket. And this is the same as what? X squared plus 4x plus 4 minus 1. And then what we're going to have is 0 is equal to x squared plus 4x plus 3. Okay, and then we factorize this. Notice that we have factors of x and x for x squared. The factors of 3 is just 3 and 1 because it's a prime number. And we can clearly see 3 and 1 gives us 4. And how are we going to do it? We're going to have x plus 3, x plus 1, if you do the factorizing method. Therefore, what this implies to us is that we are going to have x-intercepts is going to be what? X equals 2, or x plus 3 equals 0, or x plus 1 equals 0, when we let both brackets be equal to 0, such that x is then going to be equal to negative 3, or x is equal to negative 1. And the coordinates of these x-intercepts is just going to be what? Negative 3 and 0. And this one will be negative 1 and 0. Because when y is equal to 0, then it's both of these values. Okay. Alright, and then what about the y-intercepts? How do we find the y-intercepts? The y-intercepts, so the y-intercept, it's going to be only 1. You're going to notice that. Is essentially when we are going to say that x, so we need to let x be equal to 0, such that what we are going to get is going to be f of 0, right? It's just equal to what? What is our function? It is 0 plus 2 squared minus 1. Because remember, the actual function was x plus 2 squared minus 1. So we replace x with 0, and then therefore from there, we know this is just our y value at x equals 0. And then we just simplify. 0 plus 2 is 2, 2 squared is 4, 4 minus 1 is 3. So therefore this indicates to us that our y-intercept is just going to be 0 and 3. And then we just do the actual function. We need to draw it now with all the information that we have. Sorry about that pause, by the way. We're going to start drawing the function as follows. So it's going to look like this. And then what do we notice? We just put all the intercepts on. We notice that the turning point first, right? We found the turning point is negative 2 and 1. So x equals negative 2. So let's say it's somewhere here, negative 2. And then y is equal to negative 1. So let's say that negative 1 is here, such that the point is going to be like this. Okay, and it's going to be negative 2 and negative 1. That's our turning point. What about our y-intercept? It's 0 and 3. So we're going to plug that in here. When x is equal to 0, which is somewhere here on the y equals 0, x equals 0 line, which is the y-axis, which I didn't indicate. This is the y-axis. Then therefore it's just going to be somewhere here maybe. So this would be 0 and 3. Okay. And this would be the x-axis. You have to indicate those. And then what about our x-intercepts? Our x-intercepts are going to be negative 3 and 0 and negative 1 and 0. So negative 3 and 0 would be somewhere here. And then negative 1 and 0 would be somewhere here. Okay. So essentially our graph would look something like this. Because the turning point is at the minimum, it's going to go up when you draw it. Okay. Then it'll look something like this. And this is our function f. Okay, where this point here is just going to be negative 3 and 0. And this point here is just going to be negative 1 and 0. Alright, are we missing anything? Nope, we're not missing anything. We've just drawn the function. Okay, I want you to try other turning point functions and do the exact same method as I just did. Now we're going to draw the functions which have quadratic form. Alright, so here's the quadratic function. So we're going to basically follow the same exact steps, but there's only a little bit of a difference. This is not the turning point form, so we can't just get the turning point immediately. So we need to consider the following. There is a derivation to this, but I'm not going to do it now. The turning point x, how do you get the turning point x for quadratic functions? The turning point x is the same as, I'm trying to see here, you can actually get it from saying negative b over 2a. So it's in the form of x equals this, and this is actually what you call the, actually it comes from x equals to negative b over 2a, which we call the axis of symmetry. Okay, and the parabola only has one axis of symmetry, and there's no asymptotes that are involved in this case. Obviously, this is actually just a line, right? And it doesn't have any asymptote because it's also a second degree polynomial, and it's a polynomial in general. So this is essentially how we're going to find our turning point x. And then how to find our turning point y. Our turning point y is just the same as saying the function of negative b over 2a. Which is obviously like the same as saying f of the turning point x. So with the, did I say tx? What the heck is that? Turning point x. So when we find our turning point, we plug it back into our function to get the turning point y. What on earth am I doing with everything over here? It's y. Okay. You see, I probably say it, and then I don't mean it. But anyway, that is essentially how we find our turning points. Everything else is basically the same procedure, right? So let's actually solve this problem. Notice that our a value is negative. It's less than 0. So this tells us that it's just going to be concave down. Okay. The negative 10 is our y-intercept. So therefore our y-intercept, we don't need to solve for it, is just going to be 0 and negative 10. Okay. We can just state it in the problem. Basically, it's without actually having to work it out. So now this is where we start. Our turning point x is just equal to what? Negative b over 2a. And we know that our b value is equal to what? Our b value is negative 12, right? Because it's the form ax squared plus bx plus c. So b is equal to negative 12. Okay. So it's going to be negative into negative 12 divided by 2 multiplied by a, which is negative 2. Negative 2 is also a. So we just simplify. It's going to be positive 12 over 2 times negative 4, which is just negative 4. And this is divided by negative 3. Okay. So therefore, our turning point x would be negative 3. And to find turning point y, all we need to do is just say the function of turning point x, which is negative 3. And then that is essentially just going to be what? It's going to be where we plug in negative 3 into the function. So negative 2 into negative 3 all squared minus 12 into negative 3 minus 10. And then we just solve from here. And we should get 8 if we do solve for this. So therefore, we can say that our turning point has coordinates negative 3 and 8. Okay. So there's our turning point. So it's so easy to find the turning point here. There is another method, but I think this is just a better method to use. I think there was another method. I think it was completing the square or something. But don't worry about that. Here we're just going to be using this. But I think completing the square was like to derive this specific formula over here. But anyway, that aside, all we're going to find now is the intercepts. So we know our y-intercept. So we can just say our y-intercept is equal to what point? 0 and negative 10. Okay. But our x-intercept is going to be what? So x-intercept or intercepts, okay, is going to be where we let y be equal to 0, such that implies to us that we are going to have what? I'm going to rather do it just underneath for space. So when we let y equal to 0, we're essentially letting the whole quadratic be equal to 0. So it's just going to be 0, and I'm going to rather do this on another page. We are going to be letting 0 be equal to negative 2x squared minus 12x minus 10. Okay? And we just need to solve for x. So clearly we want to get rid of the coefficient in front of the x squared. So we divide... we take out negative 2 as a common factor, then we're left with x squared, and we're going to have positive 6x positive 5. Okay, when we take out negative 2 as a common factor, so every negative changes to a positive inside, and divide all of them by 2. Okay, and this is equal to 0. Then we can divide both sides by negative 2, so we get rid of that negative 2, and we're left with x squared plus 6x plus 5. And then from here we can factorize. We can say that x squared is broken up into x and x. 5 is broken up into 1 and 5 because it's a prime number only. And then from here we can only get a combination of positives. So it's x plus 5 and times x plus 1. So this implies to us that x is equal to -5 or x is equal to -1, where our intercepts are going to be at -5, our y is going to be 0, and at -1, our y is going to be 0. Okay, now we can sketch this function. So as we sketch this function, what are you going to notice here? Let's make it a little bit longer here. Okay. We need to remember that the shape is going to be what? Concave down, because it's a negative a value. So we know that it's going to have a maximum value. Okay. And let's just label this to be y. Let's label this to be x. Okay. Let's not forget. And then from here, we know our x-intercept and we know our y-intercept, and we also know our turning point. So let's just write down our turning point first. Our turning point is -3 and 8. Okay. Our turning point is -3 and 8. So it'll be -3. So somewhere here. And then let's say 8 is somewhere here. Such that when we do the actual coordinate, it would be somewhere around here. So we can call this -3 and 8. It is a maximum, so we can put the coordinate there. Okay. And then our x-intercepts are just going to be -5. So somewhere here. And then -1. So it'll be somewhere here. I'll put the -1 here. And then from here, what is our y-intercept? It is going to be 0 and -10. So let's say that -10 is somewhere here. Okay. So we're just going to draw the function now. It's going to make sure that it aligns with all the coordinates, all the dots, all the points. I just can't draw so lekker. So it looks something like this. Okay. So obviously it doesn't need to look perfect. I just recommend you try it out. But how I am drawing right now is literally with a tablet on a laptop. So it's so difficult to like judge everything. But this is G, actually. So you know it's going to be G of X over here. Okay. Alright. And we obviously write down the coordinates properly, by the way. It's -5 and 0. This one is -1 and 0. This one is going to be what? 0 and -10. Okay. And there we go. We just did all the coordinates. And that is how we sketch parabolas using the quadratics and the turning point forms.